Okay, so far we've talked about Riemann sum and Fubini's theorem, but we haven't done any calculations of integration like we did in Calc 1. So we're continuing with 15.1 and we're giving you some examples. Example 2a, let r be 0 to 1 times 0 to 1. Evaluate the double integral over r of function 1 plus x plus 2y over the area element dA. Things are so the function is continuous, so by Fubini's theorem I can do whichever iterated integral I want. And so start with one way. 2a is going to be one way, and then we do 2b the other way. And so basically I'm setting this up as two integral. Let's have the inner dx, dy, and then outer dx. 1 plus x. So the function is continuous. So by Fubini's theorem, I can write this as a iterated integral. And so let's have dy as with respect to y in the inner integral, with respect to x in the outer integral. And then y goes from 0 to 1, and x goes from 0 to 1. They're rectangular regions. It's a rectangular region. So what you do is you basically identify the inner integral, you evaluate the inner integral. I can write it over here too. When you're evaluating inner integral, it's going to be respect to, in this case, is respect to y, therefore x is going to be a constant. So it's going to end up to be, it's going to be the integral of 1 is y, integral of x is another constant plus xy, integral of 2y is going to be y squared, and it goes from 0 to 1, but it's y equal to 0 and y equal to 1. So y equal to 1 gives me 1 plus x plus y squared. Y equal to 0 gives me 0 in this case. So the inner integral, this entire thing, is 1 plus x plus y squared. Now evaluate the function that you got over in the outer integral. Oh, apologies, made an error in here. After you evaluate the inner integral, one of the variables go away, so you get 1 is 2 plus x. So the value is 2 plus x. And then take the integral of that, that's 2x plus x squared over 2, 0 to 1, and that value is going to be 2 plus 1/2, which is 5/2 minus 0. So in 2a, we evaluated the integral in using iterated integral and Fubini theorem, and the inner one was dy. What happens if I switch? And so everybody asks, what happens when I switch? So let's switch. This time put dx inside and dy for rectangular regions, right? 0 to 1, 0 to 1. This time the inner integral is that. So let's rewrite it. 0 to 1, 1 plus x plus 2y dx. Y is going to be constant, so x constant times the integral of 1 is x, integral of x is x squared divided by 2, integral of 2y is 2yx because 2y is a constant, and from 0 to 1. What is changing? Here it was x, so this should be x equal to, and x equal to 1 gives me 1 plus 1/2 plus 2y. Again, the other variable went away. And then minus 0 is all of them are going to be 0 in this case. So we have 3/2 plus 2y. Replace it in here for the integral. 3/2 plus 2y dy. And then that would be 3/2 over y plus y squared, 0 to 1. And when you compute and you plug in 1, you get 1 plus 3/2, which is 5/2 minus 0, the same answer that you got from the other iterated integral. So the change of the variable, the change of the order of the iteration does not matter, as Fubinni said. Now, let's do question 15.1. See that RB negative 1 and 1 times 0 and 1, the rectangular region like that. And that looks like this. But for which of the following functions is it true that the double integral over r of f of x and y dA is equal to 0? So we've seen that the integration, the iterated integrals in calculus 3 is very much similar to, I mean, each one of them is exactly a single variable integral. And in here, I see that this rectangle is divided into two regions that are equal. One of them is over negative x's, and one of them is over a completely symmetric about the y-axis. So if the function, there are multiple ways that this can happen, but if the function is odd with respect to x, then it's definitely the integration is going to be 0, because just think about the inner integral. If the with respect to set the inner integral with respect to x and think about it. So give yourself a quick minute and then come back. The only function that is odd with respect to x is f of x and y equal to xy squared is positive on this side of the rectangle, negative on this side of the rectangle, and completely symmetric. So if you set the iterated integral, you see that they actually cancel each other out and the integral becomes 0.